In this video lecture, we're going to estimate entropy change for different systems and different chemical reactions. Entropy is the disorder of a reaction, and delta S is the change in entropy. So if delta S or change in entropy is positive, that means there's a gain of entropy or gain of disorder. Things are moving towards more disorder. And if delta S is negative, that means there's a loss of entropy and things are moving towards more order. There's going to be less disorder. So we're going to try and estimate whether delta S is positive or whether delta S is negative, whether entropy is increasing or whether entropy is decreasing. Now, the first way in which you can figure out whether entropy change is positive or negative is by looking at the change of state. Now, if you look at the change of state, the three basic states, one is solid, the other one is liquid, and the third one is gas. Now, you can figure out on your own by looking at the state that a solid state has less entropy. There is less disorder, particles are very ordered. And on the other hand, a gaseous state is very disordered, so there is higher entropy. So this is the higher entropy state. So if you're moving from left to right, if you're moving from a solid state to a liquid state and then to a gaseous state, that means delta S is positive. There is a gain of disorder or gain of entropy, or vice versa. If you're moving from a gaseous state to a liquid state, that means delta S is negative, or from liquid state to solid state, that means delta S is negative again. That means you're moving towards more order. So moving from solid to liquid to gas, that means that the sign of delta S is going to be positive. So as an example, if I have this reaction which it's given that H2O is liquid and it changes into H2O gas, that would indicate that delta S is positive because there is a gain of disorder or gain of entropy. Vice versa, if I have another reaction which I have iodine which is gaseous and it's becoming iodine solid, that means it's going from a gaseous state to a solid state. That means disorder is decreasing, delta is negative in this case, and there's a loss of entropy. Another process that increases entropy is the process of a solid or a liquid that is dissolving. So in your image, you can see this capsule that is dissolving in water, and you can see that the disorder is increasing. The particles are becoming more spread out and they're being distributed in a more random order. So the energy is also distributed in a more random fashion. So the more organized and ordered particles become more disordered. So whenever a process of dissolving is taking place, then entropy increases. So for example, I can write a reaction in which let's say I have NaCl solid, and that solid NaCl is dissolved in water, so plus aqueous, and eventually this NaCl ionic compound dissociates. It produces ions Na plus and Cl minus 1 aqueous ions. So the solid particles have now dissociated, broken down into smaller ions, and they have also dissolved. So this dissolving process, the delta S or the entropy change for this reaction is going to be positive as disorder is increasing. And the same goes for liquids as well. For example, I have methanol, which is CH3OH. Methanol is very soluble in water, but methanol is liquid. So if I dissolve it in water plus aqueous, and methanol dissolves in water, so its particles are going to be more spread out and distributed in a more random order. So ethanol aqueous, the particles would be more disordered, so delta S would be positive in this case. And vice versa, if something is being crystallized, for example, NaCl aqueous is crystallized into NaCl solid, then the entropy change would be negative. It would become more ordered. So whenever the process of dissolving is occurring, the process generally increases entropy. The third point in which the entropy of a substance or a reaction increases or decreases, you can figure that out by looking at the number of moles of gas that are being formed or that are being consumed. So if the number of moles of gas in a reaction are increasing, that means delta S is positive because gases have more disorder, have more entropy. So if more gas is being produced, that would mean that the disorder is increasing. Vice versa, if the number of moles of gas are decreasing, that means that the things are moving towards more order. If there's lesser gas, then things would be more ordered and delta S or the change in entropy would be negative. So for example, I have two reactions in front of me. One is this reaction from the Haber process, where nitrogen is reacting with 3 moles of hydrogen and it's producing 2 molecules of NH3. Now, if you look at the reactants, you would notice that there are 4 moles of gaseous reactants and your products only have 2 moles of gaseous products. This would indicate that 1 mole of nitrogen is reacting with 3 moles of hydrogen. That means 4 moles of reactants are getting converted into 2 moles of gaseous molecules. So the amount of gas is decreasing as you move from 4 moles of gas to 2 moles of gas. So the amount or moles of gas are decreasing in this reaction. So delta S would be negative in this reaction. The entropy change would be negative. The entropy would be decreasing. 2 moles of gas would be more ordered compared to 4 moles of gas. Similarly, I have another reaction, another example in which I have gaseous water molecules. So it's steam that is dissociating, decomposing and producing 2 moles of hydrogen and 1 mole of oxygen gas. So if you look at the reactants, then you have 2 moles of reactants in your reactants and you have a total of 3 moles of gaseous product. So if you look at this reaction, you would notice that the amount of gas is increasing. So in this reaction, if this reaction takes place, then the amount of moles of gaseous products are more compared to the reactant. So the amount of moles of gas is increasing. So things are moving towards more disorder, which means that the entropy change is positive. Things are moving towards more disorder. Disorder is increasing. Entropy change is positive. We can discuss a third reaction, and in this reaction you have calcium nitrate, which is a solid, and it is decomposing and producing calcium oxide, which is also a solid, but it's also producing 4 moles of NO2 gas and 1 mole of O2 gas. So in this reaction, a total of 5 moles of gas are being produced in the products, and your reactants are solid. So again, in this reaction, since the amount of moles of gas are increasing, there are 5 moles of gas in the products, and moles of gas have more disorder. So since more gas is being produced, the disorder is increasing, hence entropy change is going to be positive again. The products are going to have a higher entropy. So there's a net gain of entropy.